Alright, today we're going on day 3 of chapter 4. We're going to start to look at section 4.2, and we're going to look at some more basic differentiation rules. This is where we are going to learn some, what I'm going to say are shortcuts, perhaps, to make taking the derivative much quicker and easier. The biggest one is going to be the power rule. You see right here. So we're going to learn that. We still need to understand the limit definition of the derivative and how to do that, and I'll show you some examples in class on why that is. But once we know the power rule, taking the derivative becomes much simpler. So we're also going to learn the constant rule, constant multiple rule, sum and difference rules, and have a better understanding for derivatives and their graphs. Okay, so first is understanding or learning the constant rule and the power rule. Alright, the constant rule says that the derivative of any constant is always going to be 0. That makes things very easy. For example, the derivative of 6 with respect to x is 0. See how that worked? The derivative with respect to x, the derivative with respect to x of x is always going to be 1. Now here, power rule. What does this say? The derivative with respect to x of x to the n is n times x to the n minus 1. So what does that mean? That means that here the derivative with respect to x of 3x squared minus 5x plus 2 is going to be 6x minus 5. So what I'm doing is I'm taking the derivative of each piece individually. The derivative of 3x squared is 6x from the power rule. So I take the exponent, I bring it down in front, in this case it's times 3, and I reduce the exponent by 1. So it was a 2 and now it's a 1. Here the exponent is 1. I bring it down in front, multiply by 5, so it stays 5, and then I get x to the 0, so the x goes away. The derivative of a constant is 0, so the 2 is no longer there. So you can see now, hopefully, how using the power rule makes derivatives much quicker and easier. Alright, so these next couple rules I kind of actually already jumped ahead to by that last example, but this rule here is saying that if I have a constant in front of a function, I can pull the constant out front and then do the derivative of the function and then multiply by the constant. So if I want to find the derivative with respect to x of 3x to the 6th, then I can think of this as 3 times dx of x to the 6th. So it's 3 times 6x to the 5th because of my power rule. So I get 18x to the 5th. You do not need to write out all of this work. I would expect you just to go right to the answer. But the property or the rule is showing you why that works. If you have the sum or difference of functions and you're taking the derivative of the entire thing with respect to x, so again, just like with this with the example that I had on the previous page here. This was technically the difference and sum of 3 separate polynomial functions, or you could think of it that way. So you can take the derivative of each part individually, again, like I did on the example on the last page. So the derivative of 5x to the 4th plus 3x cubed minus x plus 8, I can take the derivative of each piece individually. In this case, I can use the power rule. So f prime of x is going to be 20x cubed plus 9, sorry, I'm thinking cubing, plus 9x squared minus 1. So 5x to the 4th became 20x cubed, 3x cubed became 9x squared, and negative x became negative 1. Alright, I want you to try to find the derivative of f of x equals 2 over 3x squared. Pause the video, unpause when you're ready to check your work. Alright, so first I want to rewrite 2 over 3x squared as 2/3 x to the negative 2. Now I can use the power rule, so I can bring down the negative 2 and multiply it by the constant here. So negative 2 times 2/3 is negative 4/3, and then reduce the exponent by 1. So negative 2 minus 1 is negative 3. So I have negative 4/3 x to the negative third. I can rewrite that as a positive exponent as negative 4 over 3x cubed. So that is my derivative. Alright, so now I want you to find the derivative of g of x equals the 4th root of x. Pause the video, unpause when you're ready to check your work. Okay, so here first we can write g of x as x to the 1/4. Use the power rule, bring down the 1/4, and reduce it by 1. So 1/4 minus 1 is negative 3/4. So now my answer is either 1 over 4 x to the 3/4 or 1 over 4 times the 4th root of x cubed. Either of those would be correct. Alright, so next I want you to find the equation of the tangent line at x equals 1 of f of x equals x to the 5th minus 3x squared plus 4. And then also look at this again on your calculator and graph the tangent line on your calculator so you can see that actual relationship. So pause the video and unpause when you're ready to check your work. Alright, so first we find what is f of 1. So I need to find a point. Right now I only know that x is 1, what is y when x is 1, so I find f of 1 and that's 2. Now I take the derivative, I use the power rule, bring down the 5, reduce the exponent by 1, bring down the 2, multiply by the constant 3, reduce the exponent by 1. The derivative of 4 is 0, so the derivative of f of x is 5x to the 4th minus 6x. Then find f prime of 1 so that I can find the slope of the tangent line when x is 1, and I get negative 1. So now I can write the equation of my tangent line in point slope form. So it's y minus 2 equals negative 1 times the quantity x minus 1. Alright, now I want to look at some stuff on the calculator real quick to show you some more tricks. Tricks, I don't know if those are the right words, but okay, so if we put this function in, we have x to the 5th minus 3x squared plus 4. Alright, so I can graph it, and then I already showed you how we can do second draw, and then tangent, and then we want to do it when x is 1, so we hit enter, so it draws us the tangent line, it gives us the equation negative 1x plus 3 in slope-intercept form. So if we had simplified our version here and wrote it in slope-intercept form, that's what we'd end up with. Y equals negative x plus 3. But I want to show you how the calculator can actually calculate that derivative for you as well. So again, most tests and quizzes you're not going to have a calculator, but just to show you what the calculator is capable of, if you go to math, and then down here, if you actually scroll down, you'll find n derive. So I pass it here, it's the 8th one. So if I choose this, and now this notation here, I want to put in what am I taking the derivative with respect to. So that's going to be x. Here I'm going to put in the function. Since I already typed the function into y1, I'm going to do vars, yvars, function, y1. Had I not already typed it in, then that's where I would type in the function. So in this case, x to the 5th minus 3x squared plus 4. And then here I want to find the derivative when x is 1. So now I hit enter, and I get negative 1. So that was our derivative. Again, this is just more to show you the functionality of the calculator and how it can help you check your answers sometimes. Also, remember that this is imprecise, that this is rounded, or this is not exact, where we know that the actual value is 1. Alright, next I want you to find an equation for the horizontal tangent line to the function f of x equals x squared plus 2x minus 8. So I want you to pause the video and do this. If you're confused on what that would be, think about what would the slope of a horizontal tangent line be, and use that and the derivative to help you. So pause the video, unpause when you're ready to check your work. Alright, so here first I find the derivative of the function, so f prime of x is 2x plus 2, using my power rule. Now, if I want to find a horizontal tangent line, I'm going to set the derivative equal to 0, because I know that the slope of a horizontal line is 0. So, where is the slope going to be 0? Remember that that's what the derivative represents. 0 equals 2x plus 2. I solve for x, I get x equals negative 1. So that is the x value where the function has a horizontal tangent line. What is the y value there? Because I know the equation of a horizontal line is y equals a number. So now I want to plug in negative 1 into the function to find the y value. So when I plug in negative 1, f of negative 1 is negative 9. So the equation of my horizontal tangent line is y equals negative 9. Now, in this case also, since this was a quadratic function, what else did we actually find here? So think about what that is. Where is the horizontal tangent line going to occur in a quadratic function? That's going to be at the vertex. So remember, we saw this a lot in our polynomial unit, using opposite of b over 2a and f of opposite of b over 2a to find the vertex. And in this case, if we found opposite of b over 2a, we're going to get negative 1, and our y value is going to be negative 9. That's our vertex. Alright, last example, just a little bit more practice. Find the equation for the tangent line when x equals 2 of the function f of x equals x squared minus 6x plus 15. Pause the video, unpause when you're ready to check your work. Alright, so first I found f of 2, plug in 2 to the function, f of 2 is 7. The derivative, f prime of x, is 2x minus 6, f prime of 2 is 2 times 2 minus 6, which is negative 2. Therefore, my equation of the tangent line is y minus 7 equals negative 2 times the quantity x minus 2. So, again, most of the time it's going to be easier to leave things in point-slope form, unless I specify otherwise on a test. Leave it in point-slope form, or do what is easier based on the information you're given. Most of the time that's going to be point-slope form. On a test or a quiz, most of the time I'm going to specify how I want it, so make sure you're reading the directions, because I know we struggle with directions sometimes. Okay, so now we understand that using the constant rule and the power rule makes derivatives a whole lot easier and more fun. You thought they couldn't get any more fun? Bam, they just did. Wait till we learn the product rule and the quotient rule next. It's going to blow your mind.